Hi everybody, and welcome back to Mathematical Misconceptions. And today we're going to talk about a common mistake that I see when we're using complete the square when the lead coefficient of our terms does not equal 1. Now as a reminder, what is a lead coefficient? It is the coefficient in front of the term with the highest power. So we have two variables here. So in the first case we have x, and the lead coefficient is 2 because the highest power is squared. And here the lead coefficient is -3, not 3. Because in the y power, the highest power is a square. So we have to identify those lead coefficients, and then we have to play by a little bit of a different approach than just bulldozing it directly. So if you're ready, let's dive in. The first thing that I'm going to do is I'm going to go ahead and factor out the lead coefficients in both of these instances. So in this case, we have a +2 to factor out of the x, so 2 times x squared minus 4x, and then just leave a little bit of room, minus, and then we can factor out a -3, not +3, right? -3, and you have to watch your signs all along the way. So y squared, and then this used to be positive, now it's negative. Minus 4y, leave some space, is equal to 10. Okay, if you're not sure if you distributed it or you factored it correctly, you can always go in reverse, distribute. If I distribute this 2, it's going to be 2x squared minus 8x. And if I'm not sure if I factored this negative out correctly, so let's distribute it back in. -3, -3y squared, check. -3 times -4 is plus 12y. We're in the clear. All right, everybody, so this is where the common mistake usually happens. The factoring is usually not the hard part, although some people forget to factor out the negative here. So that's one common mistake. But I'm going to show you the most common mistake that I've seen when it comes to factoring. All right, so for completing the square, we know that complete the square is always going to be, take a look at the b term. So the constant that we're adding is b over 2 all squared. Now, this is the most common approach, and there is a different approach as well, but we'll stick to the common approach today, that we identify the b term, which is always the coefficient in front of the linear term, and we go ahead and put it in there. So in this case, the lead coefficient for both of them is in fact -4 by coincidence. So we can kill two birds with one stone right here. Let's plug in -4. So C is equal to -4 over 2 fully squared. And then C in this case is going to be -4 over 2 is -2, but -2 squared is +4. Whenever you complete the square, you should always be adding a number, right? Especially within the parentheses. +4 plus 4. Okay, so the inside looks really good right now, but we have these lead terms to consider. What do these lead terms actually do to the right-hand side? Remember, this is a balancing act, so what you do to one side, you must do to the other, and if you don't, then you've created something completely different, and along the way, you always have to keep the equation consistent. So on the right-hand side, we have a 10. I'm actually going to ask the 10 to move over a little bit. So let's have you move right here. And you may be looking like this. Okay, I have a, let's use a blue pen right here. I have a 4 right here and a 4 right here. So it's going to be +4 +4. Okay, so that's a good start, but the question is it actually balanced? And the answer is no, because if I distributed our lead coefficients through, you would find that you're actually adding 8 to this side and 4 to this side. That's not a balancing act. We're giving more weight to the left-hand side than the right. We got to keep it balanced, right? Similarly, if we distribute this -3 right here, we're actually taking away 12. So all of a sudden, when we're adding 4 right here, we're giving more weight to the right-hand side because we're adding 4 versus the left-hand side, which is being subtracted by 12. So you must make both of those corrections. One this way and the other this way. We have to multiply these numbers by the respective coefficients that we factored out. Now the first one is 2. So when we added a 4 right here, we actually add a 2 times 4, because if we distribute, that should be an 8 at the end of the day. So 2 times, and we'll do that in different colors. Same thing right here with the y, right? You have the -3 times 4, so it's going to be plus -3 times 4. I always tell students, start it out like this, simplify the numbers later, right? You want to make sure you have a process that's correct and reliable at the end of the day. You don't want to do a ton of mental math if you don't need to, because you could be juggling two different things at the same time, as you'll see in the next steps. Here on the left-hand side, what we're going to do is we're going to go ahead and factor. So 2 times, and then this is a perfect square trinomial. So this is going to be x, things to look for, x, what's the sign next to it? A minus. And then what's the square of the last term? 4, which square roots to 2? Squared, minus 3. Same thing again. What's the square term? Y. Sign next to it? Minus. And then square root of the 4 is 2. Squared equals, and now we can balance all this out. So we have 10 plus 8, and then this is going to be negative 3 plus 4, so it's going to be minus 12. Now in the next step, let's just go ahead and simplify that number. So 10 plus 8 is 18, minus 12 is 6. So we have 2x minus 2 squared minus 3 times y minus 2 squared is equal to 6. And then finally, if you're doing hyperbolas right now, you'll recognize that the last step that you'll need to do is going to be to divide by 6 and simplify it. Again, this lesson's only on the common misconception with completing the square and making sure that you always balance both sides when you are completing the square. Alrighty, so that is a common misconception that I see with completing the square when the lead coefficients are not 1. Again, when they are 1, it's very easy, it's very straightforward. Just add here, add there, add there. When you have these weights, such as the 2 and the negative 3, you must balance them differently. Make sure you do that for next time. If you have any questions about this lesson or any other mathematical misconceptions, please drop a comment below. Otherwise, I'll see you in the next one. Thank you.